Hello guys, welcome to Pepcoding, and now we are going to discuss the next question, that is construct BST from post-order traversal. So what we have to do is we have been given a post-order array. So by using that array, what we have to do, we have to construct the BST. BST, that means binary search tree. Okay, so this question is almost like 80% similar to my last question, that was the pre-order traversal. Okay, so in the last question what I have done is I have constructed the BST using the pre-order traversal. Okay, so this is almost 80% similar to the last question. Okay, so if you have not watched my earlier videos, so please watch that, and after that start watching this, so it will become very easy to understand this question. Okay, so let's see what we have to do in this. So this is our post-order traversal array, and this is what we have to construct. Okay, so we have to construct this tree. Okay, so this is our post-order traversal. So in the last question what we have done is we have moved towards the left side. Okay, so each and every time we were moving towards the left. If we are not able to find anything towards the left, then what we are doing, we are moving towards the right and again to the left, right. If we are not able to find anything to the left side or to the right side, then what we are doing, we were backtracking it. Okay, so the only difference in this question is that we have to traverse from the right side. Okay, so this time we have to traverse this from the right side. And why we are traversing from the right side? See, if you are traversing from the right side, that is, suppose you are traversing from the right side. So first we got 30. Where is 30? 30 is from the back side. It is the last element. Okay, then again we are going to the right side. Then what we will find? We will find 39 here. Then again we are moving toward the right side. Then we are able to find this 42. Okay, then again we are moving toward the right side, but we don't find anything, so we move toward the left side. Then we find anything. Okay, we don't find anything toward the left or right. Then in that case what we do, we just backtrack and explore some other paths. Okay, so when we backtrack, so our right call is completed. Now we have to move toward the left. Okay, so when we move toward the left, we find 35 here. The next element is 35. So there are two differences. So we are moving toward the right side, and the second difference was that we are iterating from the left to right. Oh, sorry, right to left. Okay, so in this direction we have to iterate. Now we will initialize IDX with the last element. Okay, in the last question what we have done, we have done the iteration from this side, but now we have to done the iteration from this side. Okay, so this is the thing which we need to take care of. Okay, so let's do this. So I think, let me give the range. So by default we will pass this range minus infinity to infinity. And what is minus infinity to infinity? This is the left range, that is LR, and this is the right range, this is RR. So these two things we have already seen in the last video. Okay, so you were already aware about these two things. Okay, now in the last video what we were doing is we were giving the left call first, but now what we will do, we will give the right call. Okay, so what will be our root element? The root element will be the array of IDX, that is, what is IDX? 0 1 2 3 4 5 6. So IDX will initialize with 6. Okay, so what will be the root element? So first what I'm going to do is I'm going to create the node of this element. Okay, so first I'm going to create the node. So let me create the node, that is 30. Now I'm going to check it, like, does this node lie in this range? Because this is a BST tree, so we have to specify the ranges. Okay, so that's why we are specifying the range, and we have to check each and every node, that does the node lie within this range. Okay, so what is the range from the left side? The range for the left side is it is greater than the 30. So 30 to infinity, 30 to infinity, like all the element will be greater than 30. Okay, and what is the range for left side? It is smaller than 30, smaller than 30, that means minus infinity to 30. Okay, so all the element are smaller than 30. So these are the thing which we need to take care about ranges. Okay, so now I'm going to give the left call, right call. So first 30 will create and it will become the root node because there is no element, so it lies between minus infinity to infinity. So it is specified and we have inserted the root node. So we have created this much of tree. Okay, now what we have to do, again we are going to construct a next node. That means now we are going to decrease the value of idx. Now the idx will become this, it will point towards this point. Okay, now 39 will come, so we will create a node of 39 and now we have to specify the ranges. So what will be the range of 30? So 30 will lie 30 comma infinity. That means what will be the value of LR? LR will be the value of node dot value. Okay, and what will be the value of RR? RR will become same only. Okay, so LR will be, let me write it here, LR will be equal to LR only, sorry, not LR. LR will become node of value and RR will become RR. Okay, so these by this argument we are going to pass the value of, we are going to update the value of LR and RR. Okay, so let me just decrease the size of this tree. Let me decrease the size first. No, we don't have to copy it. Let me decrease the size. So okay, so this is our tree, so I have decreased the size. So now we can shift towards the left side. Okay, now we can shift it towards the left. Okay, so now next what we will do is we have to insert 39. Okay, so we have set the range of the right side. Now we are also going to set the range of the left side. What will be the range of the left side? All the elements will be the smaller than 30. That means it will lie between minus infinity to 30. So what will be the value of LR? So this is LR. So LR will become LR only. And what will become the RR? RR will become node dot value. Okay, so these are the value which we are going to change. Okay, so does this 39 lie in this range? First I'm going to check for right. So yeah, it lies in between this range, so 39 will come here. Then again I'm going to set the range. So now what will be the range of the right side? The right side will become, right is equal to the node dot value, that is 39, and RR will become RR only, so that is infinity. And what is the left? What will be the left side? Left side is LR will become LR only. So we have called it from here. So what is the value of LR? So this is LR and this is RR. Okay, so now the LR will become 30. Okay, because see, you have created this element, so all the element will lie between 30 to infinity. Okay, so these all element lie between 30 to infinity, so we cannot write infinity here. Okay, minus infinity, sorry, so we cannot write minus infinity here. So the value will always greater than 30, so it will lie between, let me first erase this, they will always lie between 30 to 39. That means LR is this and RR will become node dot data. Okay, so this is how we are going to set the range. Now again I will going to iterate for the next one, that is not this one. Now this is our IDX, so the node will become 42. Now I'm going to insert the 42 here. Okay, so where we will insert the 42? So first I'm going to check here. So yes, it lies there only. So let me set the range also. So the range will become 42 comma RR, that is infinity. And what will be the left range? Left range will become 39, that is LR only, so LR is 39, and comma node dot value, that is 42. Okay, so now let me create one more node. So let us move IDX minus minus. So I'm going to decrease the IDX one by one. Okay, in the last question I was increasing the IDX by 1, but this time I'm going to decrease the IDX by 1. Okay, now the value is 35. So first I'm going to create the node, and now I'm going to check for the right side first. Okay, so does this node can be inserted to the right side? No, it is actually outside the range. Okay, it is somewhere this range. Okay, so it is outside the range, so we cannot insert to the right. Okay, now let me check for the left. Okay, so can we insert 35 here? No, it is also outside the range. Okay, so this condition we will handle in the base case. So we cannot go to the left, we cannot go to the right as well as left. Then what we do? We just backtrack. Simply we just backtrack. Okay, then again explore to the next steps. Now we have already explored the right side. Now we are going to check for the left side. Is 35 lie between this range? Yes, it lie between this range. So this is how we are going to insert the variable insert the node one by one. Okay guys, so let's go and code this. So now we are going to code this program in C++. So let me do the full screen. So first what I'm going to do is, first I'm going to create one method, okay, in which I'm going to code this. So I have created one function. Let me change the name. So the chain name is create BST. Okay, so this is our function. So now I'm going to create one IDX. Okay, int IDX, and I will give the default value of IDX to 0. Okay, now I'm going to change the IDX. So from where we will start the IDX? IDX will start from the back side, that is array of size dot -1. Okay, so IDX is equal to pre-order size -1. Okay, so we have initialized the value of IDX. Now I'm going to call this method. So let me remove this, and I'm going to return this. Okay, so what are the parameters which we have to pass? So first we have to pass the pre-order array, and what are some other parameters which we have to pass? We also have to pass the left range as well as right range. And what we have to initialize the left range? We have to initialize the left range by -infinity and +infinity. Okay, so let me initialize -infinity. How we can write -infinity? 1e8. Okay, and let me also initialize +infinity, that is plus value. Okay, so we have also passed the parameters. So let me receive the argument also. First I'm going to change the name to ARR, and first argument is left range, second argument is RR, that is right range. Okay, so what is the first thing which we were doing? So first what we are doing, we were creating the node. Okay, so first I'm going to create the node. So how can we create the node? By using pre-node node, and we are going to take it the pointer type. Okay, so we are going to create the object pre-node, and what will be the data? What will be the value of that node? Okay, so the value of that node is array of IDX. Okay, like first it was 30, then it became 39. So we are first we are putting the value, and then I'm going to decrease the value of idx. Okay, so see, array of idx, and then I'm going to decrement the idx by 1. Okay, so first I've created the node, and then what I'm going to do, I'm going to give the left call, give the right call and left call. Okay, so ARR, and what will be the left range and right range? So the left range is LR equal to node.well, and RR will become RR only. Okay, so what will become LR? LR will become node of value, and what will be the RR? Right range will be as it is. Okay, and we have to attach to the right side. Okay, in the last question we have attached to the left side first, but this time we have to traverse from the right side, so we are going to attach in the right side. So node of right. Okay, the same thing which we are going to copy this, and we are going to attach to the left side, and now we have to change the value of LR and RR, that is left range and right range. Okay, so what will be the value of LR? LR will become as it is only, and right range will be node of well. Okay, so let me change it. LR is same, and right range will become node of well. Okay, so we have also done this. Now I'm going to return the node. So I will return the node. So we have completed every steps. Only step left is base condition. Okay, we have to handle the base condition, and first condition is if we have traversed all the element in the array, then we have to return. So if idx is equal to -1, first condition is idx is equal to -1. Okay, then we have to return. And what are some other condition? See, we have already discussed in the last question what will be the base condition. The base condition is exactly same. Okay, so what we have to do, suppose this is our range. So if array of idx is smaller, okay, if array of idx lie in this range, then what we have to do, we have to return it. Okay, so if array of idx is smaller than left range, then we have to return. And suppose if array of idx lie in this range, that is after the right range, that means if RR is less than array of idx, then also we have to return. So these condition we have already discussed, so let me write it here. Okay, so if array of idx is smaller than left range, or we can also say that if array of idx is greater than right range, and then in that case we have to return the null ptr. Okay, so let's run this and check for the compile time errors. So we have got the compile time error, so null ptr. So let me check this. So by mistake I have used this, and let me run it now. So it is accepted. So let me submit it and check for all the test cases, and all the test cases are running fine. So thank you guys for watching this video, and we'll meet you in the next video.